Let's have some fun with manipulating vectors. Now vector A is 2, 3 components. We have vector B, which has -2 and 4 as its components. Now we want to find a vector C, which is equal to 3 times vector A minus 2 times vector B. So 3 times vector A, what does that look like? So if this is A, then 2 times vector A is twice as long, it maintains the direction. 3 times vector A is 3 times as long and it maintains the direction of A. So this is same as 3A plus negative 2B. Alright, what is minus 2B? If our B is in this direction, then negative B is in this direction, and negative 2B is twice as long in the negative B direction, like this. So what we are going to find, that's vector C, is the sum of the 3A vector and the negative 2B vector. So if you draw it out, we will get 3A plus negative 2B, and the resultant will be something like this. C, which is 3A plus negative 2B, which is the same as 3A minus 2B, which is what we want. But let's find out in component form what this turns out to be. Alright, so in component form, we have 3A, and that will be equal to 3 times 2, which is 6, and 3 times 3, which is 9, and negative 2B will be negative 2 times negative 2, which is positive 4, and negative 8. Alright, so vector C is 3A minus 2B, which is the sum of the components x and y of these two vectors above. So that will be 6 plus 4, which is 10, and 9 plus negative 8, which is 1. Alright, so that's our answer in vector notation. And we want to now find the length or the magnitude of vector C, and that's going to be square root of 10 squared plus 1 squared, which is square root of 101, which turns out to be approximately 10.05 units. Keep saying units because we have not defined what the units are. And then the angle theta is going to be tangent inverse of the y component, which is 1, divided by the x component, which is 10. And you do this on your calculator, you'll get 5.71 degrees. Make sure your calculator is on the degrees setting. Let's keep going and look at a different way of doing the same calculation. So here we are going to do the same calculation as before, but in the unit vector notation. So in this vector notation, we were given A as 2 and 3. We will write this in unit vector notation as 2I hat plus 3j hat. So what are these I hat and j hat? If this is your y-axis, if this is your x-axis, then I hat is the unit vector along the x direction, and j hat is the unit vector along the y direction. So what does unit vector mean? It means that the length of these vectors is 1, and they simply indicate the direction along x and y axes. Alright, so now you want to write vector B in unit vector notation minus 2I hat plus 4j hat. Alright, now we want C, which is 3A minus 2B, which is 3 times A vector, which is 2I plus 3j, plus negative 2 times the B vector, which is negative 2I hat plus 4j hat. So this is 6I hat plus 9j hat plus 4I hat plus negative 8j hat. So now we add the x components together. The y components do not add to the x components and vice versa. And we add the j components together. So this is the components in the y direction, and these are the components in the x direction. So this makes it 6 plus 4, 10 I hat, and 9 plus negative 8, which is 1 j hat, and 1 j hat we can also write as simply j hat. So now we know that the y component of the resultant is 1 and the x component is 10, and then again we get the same thing as before, 10 squared plus 1 squared, and theta is tangent inverse of 1 over 10. Alright, so let's look at one simple way of doing these additions when you're given positions instead of actual vectors. So let's have a position A, let's have a position B, and let's have a position C. And if someone goes from A to B and from B to C, you have to find out how much distance they go in total. So we'll call this R A B, and then they go from B to C. Let's call it R vector B C, and the resultant will be this one, which will be R A C. So RAC in vector format is the sum of RAB and RBC. So RAB vector plus RBC vector, and what you see here is B vector here, the second place, and the B vector here in the first place gets contracted. And what you're left with is A and C, which is what you get here, AC. So if you don't know which vectors to add, then you can do it using this indices contraction, but make sure that the sign here is always positive. Alright, so that is all for this video, manipulating these vectors in many different ways.